Hi everyone and welcome to my tutorial that will show you how to use my parametric cookie cutter generator that I've made for Rhino 6 and its built-in plugin Grasshopper. What exactly is it good for? Well, it's Christmas time and my Grasshopper definition will help you create nice cookie cutters like these in just a few clicks. Everything you will need is Rhino 6, idea, and I am here to show you the rest. If you do not have Rhino, that's not a problem, because Rhino is accessible as 90-day trial version you can download on the web. I will probably put a download link in the video description so you can install Rhino and you are all good to go. This video will probably consist of 3 parts. First, I will make a quick overview of Rhino for those who have never worked with it before. Then we will jump onto the Grasshopper definition itself. I will show you how to input your data, how to harvest what you need, and in the end I have prepared example of some problems that you might occasionally face and how I will tell you how to solve them. And this will be probably everything for this video, so let's get started. Okay, so first part will be Rhino overview. So if you are already familiar with Rhino, feel free to skip this part and go directly to the Grasshopper definition. I will probably put a time tag in the video description so you don't have to search for it. And let's go. Okay, so let's assume that you have just installed Rhino, you have just launched it, and now you are here and you see a lot of icons, but do not worry, we will not need the most of them. There's just a couple of functions that we need to get familiar with, and I will guide you through them right now. Very first thing that we see here is that we've got 4 viewports. We can switch between them by double-clicking the viewport name. For the movement in the viewport, we use, it's quite normal, quite usual, just use mouse wheel for zooming in and zooming out. Then we pan with a right mouse button. It applies for all views, and left mouse button is always for selection, but we will get to selection a little later. Another very important thing is up here, and it's the command line. In Rhino you have 2 options how to perform a command. You either find it somewhere in the menu, or if you know a command name, you just type it in the command line and run it, and sometimes it's a lot faster. For instance, if I was about to draw a curve, I just type in curve, hit enter, and command is running already. And now I just can choose my control points, and when the curve is finished, I press a right mouse button and it's done. If I wanted to repeat a command, easiest way is to press right mouse button again and my command is running again. You might notice right now that first point of my second curve is snapping to the end and not of first curve. It's because of snap function. That is also very important. You can access snap menu down here. You just click it. You can see all the elements that I can potentially snap to. We can leave all of them on, doesn't matter for our use. It might happen that you need to turn it off sometimes. For instance, if we wanted to draw a point really close to the end of first curve but not coincident, then it keeps snapping constantly. So you will just need to turn it off, and now it's all okay. So it was the osnap function. You can just draw a second curve. Now, as I was talking about selection, you can select object by clicking it directly, or you can use window selection. When dragging from left to right, you select everything that's inside your selection window, and when dragging from right to left, you select everything that just hits the selection window, just crosses it. So that's why selection. If you wanted to move an object, you use gumball that appears automatically. If you didn't see the gumball, you probably have it turned off and you turn it on down here, the gumball tab. When you press and hold, you can move smoothly. It also applies on the angular transformation. And when you only press and do not hold, a window pops up and you can type exact amount of transformation. What else do we need? We will probably need properties and layers tabs. When you first launch your Rhino, they will probably be stacked somewhere here, and I prefer layout where I just take layers tab, pull it out, and then tuck it back down here so I can access both tabs at the same time. We will use them for placing our base picture. In layers tab you can just create layers and in properties tab you can see all the information about object that you've just selected. For instance, I can change layers here from default to new layer that I create, and we will use this, as I've mentioned, for the base picture. What else? Might be it for some basic overview. If I forgot something, I will return back to it in a process of our step-by-step guide. So now I will just import my base picture and we can start drawing our outline. Let's say we want to make a cutter with the shape of a Christmas tree. So I found a nice picture of Christmas tree on the internet. I downloaded it, I know where it is, and how do I import it to Rhino? So the easiest way is just select your picture and drag it into viewport that you want to use. We will use a top viewport. Now we just click OK in a pop-up window and we need to draw a rectangle that contains our picture. And this is it. Now we can move our object freely, but since it's our base object, we don't want that, and for this purpose we will use layers, as I've mentioned. So I already have one layer created, but if you didn't have it, you can just right click the layers button and click on new layer, give it a name of your liking. I will call it picture and hit enter, and we've got a new layer. And now we can lock our picture layer and change property of our picture, change its layer to picture, and now it's locked and we cannot move it anymore. Now we will continue with changing color of our outline layer to red, because we wouldn't really see black on black. So just double click the color here, make it red, click OK, and it should be nicely visible. In layers tab, active layer is always marked with a tick, so if I started drawing now, my lines would still be black because I am still in default layer. I activate my outline layer, I double click it. And now I can already start drawing. What I see at the first sight is that my object is symmetrical. So we will just draw one half and then mirror it to the other side. So first I will draw my axis of symmetry. I have just chosen polyline command here. I will click somewhere near the middle. You can either use Smart Snap to create perpendicular line, or you can turn on ortho function that will only allow you to draw perpendicular, and you do it by pressing F8 on your keyboard, or just press ortho here. Now I've made my perpendicular line, I move it a little. Now I just type curve into command line, hit enter, and I can start drawing with the OSNAP function on, so I can nicely snap to my axis of symmetry. Now I need to turn off ortho mode, and I can start blocking in some basic curves. Since our object is quite simple, won't take much time. Always keep in mind that the less control points you use for your curves, the cleaner and nicer will they look. And it will also be easier to edit them. Okay, now I want my lines to be straight, so I will choose polyline command again. Draw one line, draw the other one. And I can see that I didn't really fit to my sample object, so I want to edit my curves a bit. I can either click it and edit my control point, but I will be in trouble when I get to the corner, because I have only chosen one control point and there are two control points of one another. So a lot better way to edit curves is to just select all the curves. I will use window selection for this. I select all the curves and I press this icon here that says show control points. And it does exactly what it says, and it shows all control points of all curves. And now I can just adjust everything I need. For choosing points that are on the corners, just use window selection and select them both. Now I'll have no trouble at all. Or just quickly edit my base curves. Okay, let's say this is okay. And when I'm finished, I select everything and press right mouse button to turn the points off. What's next? Now we need to take our curves and mirror them to the other side. For that we will use mirror command. You can just type in the command line again. Oh, I can't type mirror. And now, what are we supposed to do? It's always good to keep an eye on the command line, because it always tells you what you are supposed to do. So now we have to select the object to mirror, so we just do so, press enter. Now we choose start of our mirror plane, the end of it, and we are done. Often if you are unsure what to do, just check out command line, and it always gives you a hint on what should you do. So now we've got our basic outline. We can delete our excess of symmetry, we can hide our base picture, and this is our Christmas tree. We see that it still consists of individual curves. So if we wanted to join them all together, just select them and press the puzzle icon here, or we can just press Ctrl J on our keyboard, and now it's one closed curve. So now we could just import it straight to Grasshopper, or we may make some optional fillets to it, but I guess I will first import it to Grasshopper and then show you why should you fillet and where should you fillet. So let's get onto the Grasshopper definition. Okay, so I will just turn on Grasshopper using this icon. Just click it, window appears. Close everything, press OK everywhere, and Grasshopper Windows greets you in a while. And I will just rearrange my workspace a little and I'll be right back. If you have your Grasshopper running, we can continue and open a definition that you have downloaded. But before that, one good advice. Before you start messing with Grasshopper, I recommend you to save your outline, because if you were about to input some crazy overlapping curve into Grasshopper, it might eventually get into trouble and crash. So we will just save it anywhere. A desktop, for instance. Call that a tree. and we are ready to go. So we just click File, Open Document, find our definition, and open it. You can see that some wires or some commands are shining in bright colors. That's because they are lacking an input, but you don't have to worry about that at all for now. We will give them food very soon. Just a few words about the definition layout. To make it easily readable, I have divided important objects into groups. I gave them colors. And what do they mean? Blue color means an input. These are parameters that you are either supposed to give, like your outline curve, or you can tweak some parameters that are predefined for you, or you can tweak some parameters when solving problems, but we'll get to that later. Red is for analysis, because I've made some tools so that you can analyze your curve, whether it's all okay, or when you see that something's not working, you can find a solution here, because it should find a mistake that may cause this definition to crash. And green color is for output. Here you harvest your geometry that you will use or export to STL. And everything else that is blue doesn't really concern you that much. I just divided this for myself so I know what is what and to make sure that everything's organized. So basically you are just interested in colors. I was about to say that we are ready to import our curve to Grasshopper, but we are not, since I forgot to give my outline a real size. At the moment I can only guess how big it is by the squares on our canvas, but if I want to give it some distinct proportions, I just use scale function. I type scale in the command line. I pick a base point, I pick second reference point, and if I want it to be like 70 millimeters high, just type in 70 and hit enter. And now we have the size we wanted. You can see that I exploded the whole thing. That was offline, so I can join it again by pressing Ctrl J. And now we are hopefully ready to go. So if I want to import curve to Grasshopper, I just right click here, select set one curve, select our outline, and you can see that wires are now looking all fresh. Means that gave them what they needed. And now it's time to check our input. So just check the red analysis data that I've marked here. The first thing we can check is curve discontinuity. It shows you all the places where the curve is discontinuous. Now, on the corners it's quite obvious, but sometimes when you have something curved that consists of a lot of pieces, you might miss a place when your curves are discontinuous. I will show you later in my problematic curve example. You will see what it's good for. And here we've got radius analysis. I will explain later why it's here. You will get it. Initially, what we need to check is the analysis here, because the script works like this. It creates a basic shape of our cutter, and then it just chamfers the lower side by brep created here. And all we need is to check out whether breps that are created are all okay, and whether brep here is closed. And we see it's closed, and now we can connect this wire here. Just click here, drag, release button here, And now Boolean operations took place, and here we can find our final cutter shape. So you see, it's quite straightforward. If you do not want to play with the values that are predefined for you, you basically just input curve here, check here whether BREP is closed, check here. If there's nothing crazy, if here is nothing crazy, you can just connect one wire and you can harvest your result. That's all. It's all in the ideal case when nothing bad happens. And when something bad happens, you need to check the analysis. But basically, if your curve is simple and it's all okay, you don't have to check anything. Or if you, for some reason, do not like the proportions that I predefined, you can change the values here. I've described everything so it's all nice and clear. If you wanted to tweak it, feel free to do so. And now, when we've got our BREP, how do we get it into the Rhino? We can just create new layer that we call cutter. We right click here and click bake. Now we are asked to choose in which layer bake our object. Just choose cutter, press OK. And we've got our solid body in Rhino again. If we do not want this green overlay, just click Grasshopper somewhere on the canvas. We see that we are still in wireframe, so change to shaded. Click in here, shaded viewport. Now we've got it shaded. So this is our cutter in just a few clicks. But there is something to improve, and I will show you right now. Okay, so what is here to improve? First of all, in the last video sequence I've made one thing that you might be wondering how I did it. I was still in top view and I started rotating. You do this by holding Control, Shift and right mouse button at the same time. Then you release the orthographic view and you can then rotate from then on. If you wanted to restore the perpendicular view, you just go into set view, and here are self-explanatory icons of the view, so I just would return to top view. So anyway, what is here to improve? It's quite obvious that I'm creating lower chamfer by sweeping triangular cross-section along the axis that consists of the outer outline. And that naturally means that in the inner corners there will be some deviations happening. It's just because of the way the chamfer is created. So here, more surface. It doesn't cause problems when cutting your gingerbread or anything, but if you just do not like it, I have implemented a little thingy that shows you for your data input the optimal radius of inner corners when this does not happen. So if we wanted to change it a little, just delete our old shape and have to re-edit our curve. So we wanted to give it a radius 2. So for this we can just use fillet function. Here we've got some instructions in the viewport. You always have a clear instruction and then some parameters that you may edit, and you use or edit parameter by pressing the letter that is underlined. So if I wanted to change parameter join, I just press J and it changes, so I can change it back. Now if I just want to change radius, I can only type in the radius change. I type 1, press enter and it changes. But as we see here, our optimal radius is 2, so just return to 2, and now we can start picking our curves that we want to fillet. So I press here, And it's done. And now Grasshopper started recomputing, and it took quite some time. So if you want to fill it faster, just disconnect this wire here, because Boolean operation here takes most of the time. So I just press Control on my keyboard, I press hold, drag, and release. And wire is disconnected, and now we will go a lot faster. So just switch to Rhino, press right mouse button again, and can continue with filleting. And anything that is not disconnected, so all these operations here, they always recompute when I change the base curve. You also have sharp inner corner here, but we will just leave it. Or not, yeah, we just leave it. I just wanted to demonstrate what happens. So if we look at the outline now, now looks more sleek, even the inner corners. Do you see it? If I just checked the Europe here is all okay. Still, just connect my wire. Bake my final B wrap. Oh, sorry. Misclicked. Yeah. When I still have command in Rhino running, baking is not possible. So I just click in Rhino, press escape to end a command that is running, and now I can bake. And it's here. Turn off the Grasshopper. And now you see that now we've got nice line all the way along, except for those sharp corners down here that we did not fillet. But it's not much of a deal. When creating cookie cutters, you don't want too sharp corners anyway, so I guess that's not much of a problem. Another thing that we might want to improve is we could just chamfer those edges here, so it prints better and it's more convenient to press against it. But I see one error down here. So I am using automatic fillet for the inner curve that I offset. But here our fillet didn't happen, and I can explain why. Because Rhino doesn't like it when you create fillet and it crosses another fillet. Here on this surface, just not enough space for a fillet to be created. It probably would end somewhere here, and it's not a fillet. Rhino just doesn't compute it. And so how do we solve it? We go back into our input parameters, and here is parameter round sharp corners. And what do I use it for? Here I input my curve. I'll just hide it. Wait a little. This is our input curve. And here I automatically fillet every sharp corner by value defined here. And all of that happens for all offsets that are made later on. So if I just offset it outside, and I'm doing it a couple of times, I always fillet every sharp corner of this value. And since there was not enough space for 0.5 to fit in there, we can just decrease the value. So we double click it, decrease it to, for instance, 0.3, hit enter, and let Grasshopper recompute. There's nothing shining red, everything seems to be okay. Click in here, and you can see that now we've got radius down there. So everything is working. So now we can bake it in. Now we have got continuous edge all around that we can now easily chamfer. It doesn't really matter which radius do you use for the inner corners, but I recommend it to be bigger than 0.2 millimeters, because smaller than 0.2 sometimes causes strange things, especially with this B-rep that you then subtract from the original solid. So this value should be 0.2 and bigger. But the bigger it is, the more problems you may potentially face when fitting in your fillets. So just I would leave it somewhere between 0.3 and 0.5. So okay, now we've got our shape, and if we want to chamfer the corners here, we will do it directly in Rhino, because it will be 45 degrees chamfer, and that is what Rhino can construct. So here we choose we choose solid tools, and here is chamfer edges. Click it. Now we're asked to select edges to chamfer, and we want to chain the edges, so we don't have to choose each individual edge. So we just press C, enter, and now it shows us whole loop. And we just press enter, enter, again. And yeah, it broke up because I forgot to change my chamfer parameters. This is what happens when your chamfer value is too big. It just doesn't fit in. Rhino creates some surfaces, but they are defective. So we just press Ctrl Z, press right mouse button to run the command again, and we see that we've got chamfer distance 1 millimeter. That's too much. I stick with 0.3 and it works quite well. So I just 0.3, C for chain edges, I select, enter, 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 and it broke up. And I know where this is coming from. The defective geometry gives you a hint that problem is here. Is the outer corner, and the problem is that I have chosen chamfer 0.3, but the radius here is also 0.3 as defined here. What that means is there is no place for fillet to be created, and the chamfer just explodes here. So you can only chamfer for values that are smaller than round sharp corners parameter. So we press Ctrl Z again, run the command again. Oh yeah, and now watch, we just change our chamfer distance to 0.29. Press C for chain edges, select the edges, enter, 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 and now it should construct. Yeah, now it does. See? So if something mysterious happens, just remember this. Now we can just repeat the command, do the same for the outer edge, and this is what I would call a finished shape. Only thing that you might consider a problem is this deviation here, but as I've mentioned already, I've tested this and it completely does not matter. It's just you have no idea it's there when you are cutting with it. So don't worry. If you are a perfectionist, you can repair that, but you don't need it. It doesn't need repairs. So if we wanted to export our cutter to STL, we just choose File. Oh, sorry, we first select our cutter, and we say Export Selected. Here we choose STL, give it a name, for instance tree, click Save, and this just asks you what is the maximum difference maximum distance between the Rhino surface and the surface of STL, between the mesh of STL, 0.01 millimeters. It's very precise. We can even decrease it to 0.01 and everything's gonna be okay. I may demonstrate that the more strict is your tolerance, the bigger will be the file. Now we have got 46,000 triangles. Just click cancel. we are about to export again. STL, tree, save. Our tolerance more strict, and now we've got more than 3 times as much triangles and 3 times bigger file. Get it? So doesn't really matter, but if you want to save space, you can always decrease. And now we've got our STL that we can import to a slicer, and yeah, can just make it and make our relatives happy. So that would be for our step-by-step guide. I've already shown you some troubleshooting, but there are other problems that can happen, and I will cover them in next part of my tutorial. Okay, so what else might happen to our curves? I will import my sample curve. It's quite more complex than the tree that we have just made ourselves. You do not have to draw your curves, you can just import them. You can download anything from the internet and import it to Rhino. So I'll just choose import here. And on my desktop I have this beautiful moose lady I've created for my girlfriend. I've created whole moose family. Feel free to download and print them. They are really lovely. So here is our moose lady. We will import her to Grasshopper. Set one curve. We will overwrite our Christmas tree. And what happened now? We see some error here. It's already something wrong. If we check in here, it says, what does it say? 2 open B-reps. Show us preview. Something bad happened in here. This is not nice. So now we have to play Sherlock Holmes and find where the problem is. So first thing I check is curve discontinuity. I see. Oh, okay. I see that I have 2 problems here, 2 discontinuities that are not clearly visible. This is what I was talking about, yeah? It might look like that curve is perfectly continuous, but it's not. So I have 2 discontinuities. How do I repair them? I just click in here and use command. It's called match. Press enter and follow instructions of the command line. First, we choose curve that we want to change and pick it near the end. So we just click here. Oh, sorry, I forgot to explode the curve first. So we just explode our geometry, and now we can make repairs. So type in match, select our curve near end, select the other, and pop-up window shows, which asks us which continuity do we want to create. Here we want to create tangency, and then which continuity we want to create on the other side of the curve. We want to keep tangency. Sometimes you may just stick to position, but here we keep tangency, so press OK. And the other discontinuity was hidden somewhere here, so we just right-click, repeat the command. Consider which of these curves we want to change. Let's say the longer one. Changes the geometry a little, but we don't really care. Tangency, tangency, OK. Now we press Ctrl J during our outline again. Have to reinsert to Grasshopper. Let it recompute. I might have disconnected those solid operations. Like if I didn't say that. Oh, I'm so dumb. Okay, now this indicates that there are no discontinuities. See? No values. Now how does our Europe look like? Still broken. We check our radius. Now the radius analysis works. Radius analysis, as I've mentioned, is about the deviations, and it says that in inner corners that are marked, deviations will occur. You do not care about the outer corners, because you are sweeping on the outer rail, you're offsetting the initial curve outward, so the outer corners will always be okay. The deviations only happen in the inner corners, so we basically have 3, maybe 4 places where deviation will happen. But we will check that later. For now, there's nothing to check because our BREP is still broken. And okay, discontinuities didn't solve our problem. Radius may give us a hint. This radius looks quite mysterious, so we might want to look onto that. If we look closely, something wrong here. It looks like the outer rail, you can see the fillets everywhere. Here is a fillet, here is a fillet, here is nothing. Might indicate a problem in here. So we may want to find our... Now you have to dig in through the code, you have no other way. We need to find our offsetted curve. That will be hidden somewhere here. Yeah, here it is. This is the curve that concerns us. And you see fillet here, fillet here, fillet everywhere, but not here. So what's wrong? We just zoom in. And now we see the problem. We got into a very awkward situation where offset caused that there is no sharp corner here, or to be more precise, there are 2 sharp corners, and Rhino attempts to create 2 fillets, but there is not enough space for them. If there only was 1 sharp corner, there would be no problem creating fillet, but since there are 2 very, very close to each other, fillet just doesn't create. And now at this point there is no other solution than to recreate our initial curve. So how do we do this? Okay, I won't be stupid anymore. I disconnect this one. Control, hold, drag, release. Disconnected. Return back to Rhino. Explode my initial curve. And I want to recreate this arc to ensure that sharp corner is produced here when offsetting. So I want to make it sharper. How do I do this? I will have to find a respective command, and it is here under the fillet curve command, fillet curve group, and it's called adjustable curve blend. And by the way, if you run command using icon, above the command line you can see what you need to type if you wanted to run it using command line. So it's called blend curve. And what do we do now? We choose first curve, choose the second curve, and now here we choose which continuity do we want on our curves. If you know the theory behind curvature and tangency, just can change respectively. We will stick to curvature, make it a little shorter, nicer. And if we use this, it might solve our problem. Just OK. Now we delete the old arc, select everything, join again, reinsert to Grasshopper. Set one curve. Let it recompute. Check our surface. And now it's all okay. So now, if we connect this one wire and wait a second. Pressing Control Shift and right mouse button to rotate. And now we've got our shape. And it seems to be quite okay. And as I was talking about the deviation analysis, just hide it. If we mark it, yeah, look, deviation will happen here, 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 and maybe here. And if we look at our final B-rep, just bake it to the cutter layer. You look at those respective places, you may notice slight differences in distance between here and here. But deviations like this are very small, and as I've mentioned, you don't have to really care about them. So now we've got our cutter. We can check our outer edges, whether they are continuous, and if they are continuous, we can chamfer them again and then export our file for 3D printing. And there is one more error that might happen and that I want to cover, and it is about curve seam. Each closed curve has a starting point which is the end point at the same time, and from that particular point I am extracting the cross section of lower chamfer that I drag around this rail. It might happen that your curve seam might be placed somewhere near a fillet or something like this, and it might cause this sweep to crash. So if that potentially happened, you can change value of curve seam in here. Just double click, type a value from 0 to 1, anything, for instance 0.5, and let it recompute. And you can see that the position of our curve seam changed, and it sometimes might solve your problem. With this particular one, we didn't have to change it, but oh yeah, we did, because the default value was 0.3. We might as well check what happens when we let it 0. Let recompute. Does it still work? No, it doesn't. You can see that when we have our curve seam on 0, it's here, near the fillet, then it doesn't work. See, this default curve seam, and this is the new curve seam. So it's placed right next to the fillet, and it causes sweep to crash. So in cases like this, you just type different value than 0 and then 1, because 0 and 1 in that kind of sense is the same point. So we just stick with 0.5 or 0.3 that we know worked before. Let recompute, and it should be all okay. I hope you get what I'm getting at. Just occasional error fixing. Yeah, now it works perfectly. So what have we done? This was our initial curve seam, and now we've got curve seam here in the middle of a curve, and it will work perfectly. So I hope you understand what all the analysis is for. Yeah, I might also tell you what this one is for. I've talked about that one that tells you the optimal inner radius. That one is just informative. because you are determining the lower chamfer by this size and this angle, and that one just tells you how high the chamfer is, distance from here to here. Just information for you, so you don't make it too big, you know. So, this is it. I know it might have been quite exhausting for you, but I honestly wanted everyone to be able to create his own cutter, cause girls just like it when you create cutters for them. And also, I wanted to cover all potential problems that might occur, and I wanted that you are able to solve them and that you can enjoy yourselves creating your Christmas moves and so on. So now that you've suffered through a whole tutorial with me, I am pretty sure that you can create anything. And as a reward that you have stayed with me the whole time, I will show you some cutters that I've created and a proof that they do work. So here is our Christmas tree. Here is Father Moose. You can see that you can even create quite complex shapes. You don't have to stick with just squares and triangles and so. Here is his wife that I've used to show you some bugs. Are they babies? It's tree again with some finished cookies. A comet and a carp. So, what else, guys? You are ready now. Just go out there and make your wives happy. I want to wish you all Merry Christmas. It was Tony with you, and see you next time. I also have one more bonus for you guys, and it is a fairy tale about why is this definition so big when it only performs some basic offsetting, extruding, filleting, and so. In short, it is because of Grasshopper's ingenious ability to produce bugs when you expect it the least. For instance, this wouldn't be here if Grasshopper uh, didn't produce bugs when using Boolean union. Sometimes when using Boolean union, it does intersection instead. So it varies for every curve. Sometimes it just did intersection instead. So I had to perform both and then choose the correct one according to volume of created solid. This here, all this here, is just radius analysis. Wouldn't have to be here. This, and this wouldn't have to be here if Grasshopper was able to offset curves on the correct side every time. But sometimes it was offsetting using positive value, it was offsetting outward, and sometimes using same value was offsetting inward. So what I've done basically was I have to offset on both sides and then choose the longer curve or shorter depending on what I needed. Also this and this don't have to be here if Grasshopper was able to, yeah, solve Boolean operations of objects that have coincident walls. But sometimes it just causes him too much problems, so you know, like half of this script is just debugging. This and this and this, this, also this, with this, and this and this. So now you see, this all is the source, and this is what actually works. And by the way, this wouldn't have to be here at all if Rhinoceros 3D was able to create a chamfer that has a different angle than 45 degrees. Please somebody who knows Rhino. If Rhino is capable of doing uneven chamfer, please kill me, because then then all of this work will be pointless, basically. So if you wondered why the definition is so big, here is your answer. And it's everything from me, and enjoy yourselves. Goodbye.